Welcome back to Summarize Science. Ever been stuck in rush hour traffic and wondered if an AI could have predicted this mess? Well, for years, researchers have been using AI to forecast traffic, but a new paper reveals a major problem. Most of these AIs have been trained on the wrong kind of data. For a long time, traffic data has only come from a small number of sensors placed on major highways. As you can see in these top images, it's like trying to understand an entire city's traffic by only looking at a few freeways. The connections between roads were often just guessed based on distance, not the actual street layout. This method completely misses the complex traffic patterns happening on the smaller city streets where most of us actually drive. To fix this, the researchers created two brand new, incredibly detailed datasets called city traffic. Just look at the difference in these bottom images. Instead of a few hundred data points, their maps contain up to 100,000 unique road segments for two major cities. They use GPS data, which means they have traffic information on nearly every single street, not just the big highways. Furthermore, they mapped the actual road connections, creating a true digital twin of the city's road network. Their new datasets also include rich details for each road, like speed limits, number of lanes, and road quality. So, what happened when they tested the current, state-of-the-art traffic prediction AIs on this massive new data? It turns out most of them couldn't handle it. As this table shows, many of the complex models were incredibly slow, taking days and days to train. One popular model even failed to finish training on the largest dataset after more than 250 hours. This proved that while today's AI models are clever, they're just not built for the scale and complexity of a real, entire city. So, the researchers proposed a new, much more efficient approach. Instead of a complicated method that gets bogged down, their model takes a simpler, more direct approach to learning from past traffic patterns. Think of it as a leaner and smarter AI, built specifically for this kind of massive-scale problem. And the results were astounding. Their simpler model wasn't just drastically faster, training in a couple of hours instead of days, but it was also more accurate at predicting future traffic. So, let's recap the important points. The researchers built the most detailed urban traffic datasets ever released, capturing the true complexity of city driving. They proved that many existing, overly complex AI models can't handle this real-world scale. And finally, they designed a new, simpler AI that is both faster and better for citywide predictions. What does this all mean for the future? This work paves the way for much smarter traffic forecasting systems. Imagine navigation apps that can predict a traffic jam an hour before it even happens with pinpoint accuracy. It could lead to more efficient delivery routes, better city planning, and maybe, just maybe, a future with a lot less time spent stuck in traffic. Thanks for watching Summarize Science.